The density of water at 0 degrees Celsius is very nearly 1000 kg per meter cube. We'll assume that. So there's the actual density. Where the density of ice at 0 degrees Celsius is 917 kg per meter cube. Calculate the pressure necessary to keep the ice from expanding when it freezes, neglecting the effect such a large pressure would have on the freezing temperature. This problem gives you an indication of how large the forces associated with freezing water might be. All right, so uh, we have a container containing water, let's say, and then we freeze this, okay, and it's become ice. So what is the force you'll need to apply to keep the ice from expanding? Okay, and the bulk modulus of ice is given by 2 into 10 to the 9 pascals, Newton per meter squares. Okay. All right, so the bulk modulus is the stress, which is the pressure you have to maintain, divided by delta V by V. Okay. So delta V by V, okay, the negative sign tells you the volume decreases when you have a compressive force, stress. Okay, the density of water is mass divided by volume, and that's equal to 10 to the 3 kg per meter cube. The density of ice, the same mass, so this is water, volume of ice is 917 kg per meter cube. Okay, so M water, and we'll divide these two equations. M volume of ice equal to 1000 kg per meter cube divided by 917 kg per meter cube. Okay, that cancels, so, and this is equal to 1.09. Okay, so what we have is, so this is the volume of ice comes to the top. So what we have is volume of ice over volume of water equal to 109. Okay, what this number means is when you freeze water, the volume increases by 9%. Okay. All right, so the change in, if you want to, so this number will have to be, okay. So what we'll do is we'll subtract this by 1. V ice minus V water, VW equal to 0.09. And this is, so in the previous equation, in this equation, the change in volume for the ice to keep it contained in this container would have to, is equal to this, equal to that. Okay. So the volume of water in, well, when you froze water, its volume increased from here to there by 9%. Okay. All right, so going to the bulk modulus. So going to the bulk modulus is force over area, and now we'll just do um, delta V by V. Okay. And what is it that we're calculating? Calculate the pressure. Okay, so we're calculating the pressure. Okay, so force over area equal to, okay, the bulk modulus is 2 times 10 to the 9 Newton meter square, and the pressure is minus 0.29. This change in volume is, okay, oops. All right, so this is equal to, this became positive because decrease in volume was, this was minus 0.09%. The volume decreased. Okay, negative of negative makes it positive. Okay, so this is equal to 18 into 10 to the 7 Newton meter square. Okay, and this is 1800 into 10 to the 5 Newton meter square. And so this is a surprising number. This is 1 atmosphere, so it's 1800 atmospheres. So the pressure you would have to apply to prevent ice from expanding would have to be 1800 atmospheres to maintain the same volume as the water. Okay, that's an enormous pressure.